In this video, we are going to cover assignment 8. So you can see here, this is the instructions for assignment 8. Okay, so basically we want you to follow this tutorial and to demonstrate that you understand how to generate shell code and then inject the shell code inside of a string into a variable program so that the variable program will run the shell code. Okay, so this is the variable program. So you can see the program is very simple. It has one main function. Inside of this main function, we have a buffer, which is 64 bytes. Then we have this string copy function, which will copy the command line argument into this buffer. Because string copy doesn't check the boundary of the buffer overflow will occur. So basically in this special case, if the argument contains malicious code, then malicious code may run. Okay, we'll see how this will happen. So we have 4 steps. Okay, so this is the first step. Okay, so the first step is to get the WinExec address. The reason we need this address because in our Mario code, we are going to use WinExec to pop up the calculator app, right? And we will run the calculator app and pop up the calculator. So we are going to use a program called Arwen to get that address. Then in step 2, we are going to create the shell code. So we have the source code of the shell code, and it is here. So this is the shell code. So in this shell code, you can see here at line 8, we start, the code section. And then here, what we do with these 4 lines of code is we actually create, calc.exe and this string, and then we put this string on the stack. Okay, and so here, those are ASCII codes of .exe. Here, these are the ASCII codes of calc. Okay, and so because the string should be terminated with a null, that's why we use XOR and get ECX to 0. Then so you can see by doing this kind of a push, we basically put calc.exe on the stack. So then you can see we move ESP to ECX at 918 here. So basically now, so ECX refers to the address of calc.exe because we just actually pushed this string onto the stack. Okay, so then we push 1 to the stack, then we push ECX onto the stack. We need these 2 pushes because we are prepared to call WinExec, which requires these 2 parameters. So then you can see we move, the WinExec address. So you need to use a new WinExec address we move that into EAX. Then we call EAX. Basically, we call WinExec. So WinExec will get its 2 parameters, right, from the stack. That is the string and also the window style, right? And then basically we will be able to run calc.exe and pop up the calculator. So this is the malware code. Of course, it's not so malicious. Okay, and then here, that's step 2. So now, you know, we do step 3 here. So step 3, we use a Python script to create the malicious string that will be fed into the victim program. Okay, so where is our malicious, where's our exploit script is here. So basically you can see here, right, we have this Python script, and we first actually create the malicious string, which starts with 2590. 90 means doing nothing, which is an instruction actually. Then next, this is the shell code, and we need to actually generate the exe file, then get to the binary code out of the exe file. I'll show you later. So then we have another 26 of 90 because we need to make sure the string is long enough to overflow the buffer, right? And then the last part of the malicious string is the address. So this address is the address of the first 90 here. So basically, this address is the address of the buffer, right? The buffer, this one, okay. And so we come back. So then you can see how within this Python script, we actually store the malicious string into an environment variable, and then we start another command prompt here, so which will inherit this environment variable, so that we can use the environment variable as an argument for victim program. Okay, so that's our step 3. So step 4, so basically you can see here we generate this victim3.exe. Then here we use Python 2.7 to start the exploit program, right? The exploit script. So here Python 3 is more secure, and we have to do more things with our Python script. So that's why I'm using Python 2.7, and we can just run it without problem. So once we actually run it, you can see we really start a command prompt. That's why you see such message here. So finally, we feed victim3 with this command line argument. So remember, this is our environment variable, right? So, and basically this will pop up the calculator. Okay, so there's a whole story here, and so later I will talk about how actually we can get the malicious code address, right? So let me give you the demo now. So this is our Windows VM. Okay, and so I start the command prompt. So let's change the folder to this assignment 8 folder. So we have everything here. Let me delete all the exe files. Okay, good. So let's go over all the steps. Right, so that's step 1. We get this WinEXEC address. Good, so this is the address. So I mark it, right click, then I'll copy the address. Then we go to our source code of the malicious code. So as I mentioned, we need to change this address, which is the WinExec address. And then, okay, we need to actually, assemble the code in step 2, right? So then we actually link it. So finally we create the exe file. So actually we can run it. So you can see this exe file will pop up on the calculator. So we need to dig out the binary code. So we need to open it. So actually it's here. Okay, I just opened it. And then we drag, highlight the binary code here, and just copy it. So we do the binary copy. Okay. So let's look at our step 3 here. So step 3, our step 3 is we actually create a we need to actually do this, right? We need to actually change this Python script. So the Python script is here, and so this is what I'm going to do here. So you can see this is the binary code, and we need to give it the right format so that it can be put into the string. Okay, and so this is called the escape character. And so in this way, we tell Windows this is a character. Okay, I'm going to replace the space here using the search replace function here. So basically, here's the space will be replaced with /x. Okay, and so we just need to replace this part. So that's all. Good. Okay. And then we do step 4 here. So step 4 here, we can actually create the victim program. Then we run the explode Python script. Okay, then we feed the victim program with the malicious string, which contains our malware code. So this should pop up with the calculator. So yes, it's correct. Okay. So here you may wonder, how can we get this malware address, which is actually the address of the buffer, right? We did it before, so it's quite straightforward. So let me show you how we do it. So basically, in this case, right, we need to use email debugger, and so we debug the program. We want to find out where the command line argument is copied on the stack, right? And so I'm going to use idfree where to find out, where is our main function, because I need to know the address of the main function to perform the debugging, right? Okay. Okay, 1590. So then here we come back to this emu debugger and we load it. We load the victim3.exe. So I give a long string as argument. Okay, this shows you have to restart the program so that the argument will take effect. So that's what I'm doing here. Good. Okay, so if we want to set a breakpoint at the main function, right? 1, 5. Let me see what's wrong here. 1590 401590. Did I actually quit? Oh, I did this wrong one. I loaded the wrong one. Okay, so I need to load victim3.exe. That's why I was confused. Okay, then we give it an argument. Okay, then we restart. So as I mentioned, I need to find the 1590. So it's here. Okay, I already set a breakpoint over there, so we can just run it. So I set another breakpoint after the string copy. So then we just need to find out where are all the A's, and we will be able to find the start of the buffer. Okay, so now you can see all the A's are copied to this location on the stack. So it is 61FEB0, same as what we put here, 61FEB0. Okay, so this is the whole story.